Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to satellite communication systems. So we'll extend our discussion on gravitation. So in this video, we are going to discuss a very important concept, which is the concept of inertial and gravitational mass. Okay. So it involves some basic concepts related to laws of motion, Newton's laws of motion, and Newton's universal law of gravitation. Okay, so before going deep into inertial and gravitational mass, first we'll discuss the term inertia. So we are all acquainted with it. So basically inertia is the property of an object because of which if it is in a state of rest, it is not moving, then it will continue to remain in that state. It will remain at rest. If it is moving with a uniform velocity in a straight line, then it will continue to move in a uniform velocity in a straight line. Okay, so unless and until there is some external opposition, some external force that causes to change that state, then the state of rest and the state of motion, it continues as it is. Okay, so if a body is in rest, it will continue to remain at rest. If a body is in motion in a particular direction in a straight line, then it will continue to do so with the same velocity in the same direction. So there are three different types of inertia. One is inertia of rest, second one is inertia of motion, third one is inertia of direction. So each one of these three is included in this statement. So basically inertia of rest is the property of a body. Suppose it is at rest, it will continue to remain at rest. If some external force is applied, then it will get into motion. It will move with a certain velocity. And if an object is in motion, it is moving with a certain uniform velocity in a straight line, unless and until an external force is applied to stop it, it will continue to do so. In this case, initially the box was at rest, then some external force is applied in a particular direction, then it was in motion. Here the ball was rolling down in a straight line with a certain velocity and it was stopped by this boy. So external force is applied here to oppose motion, here external force is applied to cause motion. So it was initially at rest, external force caused it to move. Here initially it was in motion, external force caused it to stop, to be at rest. And the third one, which is the inertia of direction, is that if an object is moving in a straight line in a particular direction, then it will continue to do so in that direction unless and until some external force causes it to change its direction. Okay, so basically this is the statement of Newton's first law of motion, which is the law of inertia, which states that every object continues in its state of rest or uniform motion. Uniform motion means motion in a straight line with a fixed velocity, uniform velocity in a straight line, unless and until it is compelled by some external force to change that state. Okay, so it basically says the same thing. An object in rest, it will continue to be at rest. An object in motion, it will continue to be in motion, and it will do so in a fixed direction. If it is in motion, it will do so in a fixed direction until and unless some external force causes the object at rest to be in motion, the object in motion to stop, or the object which is moving in a particular direction to move in a different direction. Okay, so this is Newton's first law of motion, which is the concept of inertia. Then we have Newton's second law of motion. So basically Newton's second law of motion states that the rate of change of momentum of a body, it is directly proportional to the external force applied on it, and the change takes place in the direction of the applied force. So momentum is basically product of mass and velocity, so it is a vector because velocity is a vector. So momentum p vector is equal to m v vector, where v is the velocity. Rate of change of momentum dp by dt, it will be d by dt of rate of change of momentum with respect to time, so d by dt of mv. So here mass is constant, so it will get outside, so it is dv by dt. Now we know rate of change of velocity with respect to time is acceleration a. So dp by dt, it is equal to mass into acceleration, the product of mass and acceleration. Now rate of change of momentum, it is directly proportional to force, so force is equal to mass into acceleration. Okay, force is proportional to both mass and acceleration. Why? Because rate of change of, according to this statement, rate of change of momentum is directly proportional to the external force. Now rate of change of momentum is mass into acceleration, so force will also be equal to mass into acceleration. F is equal to mass into acceleration. So suppose we have an object of mass m and a certain force F is applied to it, then it will move with an acceleration a. Okay, where a is equal to F by m. Okay, here the acceleration a vector is equal to F vector by m. So if it has a mass m, a force F is applied, then the acceleration produced will be equal to force per unit mass, F by m. Okay, now this mass here, okay, this mass here, this is called as the inertial mass. Okay, this mass, which is force by acceleration here acceleration is force by mass. So if we take this in the other way, so mass is equal to force vector by acceleration vector. This is called as the inertial mass. Okay, the inertial mass. Okay, this mass is called as the inertial mass, which is basically the external force applied on that object, on that mass, divided by the acceleration produced. This concept or this mass is called as the inertial mass. So basically this mass, it basically gives us an idea, a measure of the inertia of the object. Okay, the ability to resist or oppose the generation of acceleration, the generation of motion. Okay, so always remember this type of expression, whenever an external force is applied on a certain mass and it moves with a certain acceleration, according to Newton's second law of motion, this representation of mass or this equation of mass, which is equal to force, the external force applied divided by the acceleration produced, that is the inertial mass of the object, because it is a measure of the object's inertia, the ability to oppose motion. Okay, the ability to oppose motion, inertia, whether it is inertia of rest, inertia of motion, or inertia of direction. Okay, so this is the concept of inertial mass. Then we have the gravitational mass. So for that we have to go for Newton's universal law of gravitation, which basically states that every body in the in the universe, every object in the universe, it attracts every other body with a force which is called as the gravitational force. The gravitational force is directly proportional to the product of the two masses of the objects and inversely proportional to the square of the distance between them. So suppose we have two objects of masses m1 and m2 with a separation distance small r, then each exerts a gravitational force F on the other it attracts the other object towards itself with the gravitational force capital F, which is equal to G capital G m1 m2 by r square, where capital G is the universal gravitational constant. Now here let's say one of the objects we take as Earth, okay, Earth, and the other object be any other object. In this case we are taking a satellite, okay. So let's say Earth has a mass capital M and the satellite has a mass small m. They are separated by a distance small r. So the gravitational force acting on the satellite because of Earth, it will be equal to F subscript G is equal to capital G capital M small m by r square, where capital M is the mass of Earth and small m is the mass of the satellite. And if the object is on the surface or very close to the surface, in that case the separation distance is taken equal to the radius of the Earth, okay, and in that case the gravitational force is equal to G capital M small m by capital R square. So we can write this Fg is equal to G capital M small m by R square as Fg is equal to small m into small g, because acceleration due to gravity small g is equal to gm by r square, okay. So in this case it is r is equal to capital R, here r is equal to capital R, so gm by r square, this becomes acceleration due to gravity here, okay. So here we will change it as capital R, okay. This is acceleration due to gravity. So Fg is equal to mg. Now here if we write this mass m as the ratio of the gravitational force divided by acceleration due to gravity, mg is equal to Fg, that is the gravitational force divided by acceleration due to gravity, that is called as the gravitational mass, okay. This ratio of the gravitational force of Earth by the acceleration due to gravity, this ratio is called as the gravitational mass. This is called as the gravitational mass. So here this mass, which is the ratio of the external force produced divided by the acceleration produced, that is the inertial mass, and this ratio of the gravitational force acting on the object divided by the acceleration due to gravity, that is called as the gravitational mass, okay. So at first it can be a bit confusing, so always remember, whenever any force other than the gravitational force is acting on the object, the acceleration which is produced because of that, so the ratio of that force divided by the acceleration produced, that is the inertial mass, okay, that is the inertial mass. Any force other than the gravitational force acting on the object, this force can be because of a man, machine or anything, but when gravitational force of Earth comes into play and acceleration due to gravity comes into play, that ratio is the gravitational mass of the object. So here I am representing inertial mass with m subscript I, mi, okay, and gravitational mass as m subscript small g, okay, m subscript small g. This is the gravitational mass. So the mass of a body which determines the gravitational pull of Earth acting upon it, that is called as the gravitational mass, and the mass of the body which gives us a measure of its inertia, that is the ability to resist motion, that is called as the inertial mass. So any other force other than the gravitational force, that is inertial mass, When gravitational force comes into play, that is gravitational mass. Now we have to find out a relationship between the inertial and gravitational mass. Suppose we drop an object of, let's say, inertial mass mi from the top of a tower. It drops down with acceleration due to gravity small g. Gravitational force is acting upon it. So in this case, the external force which is acting on it, okay, the external force which is acting on it, which is causing an acceleration small g, that is the gravitational force. So in this case, the external force acting on the inertial mass, that is the gravitational force, and that produces an acceleration small g. So in this case, we can write mi small g is equal to Fg, which is the gravitational force. So in this case, the inertial mass for an object freely falling under the influence of gravity, the inertial mass is equal to this much. Now, the gravitational force Fg, we can write it as this g mg by r square, where capital G is the universal gravitational constant, capital M is the mass of Earth, mg is the gravitational mass. Okay, mg is the gravitational mass. So we can here establish a relationship between mi and mg. So mi by mg will be equal to gm by small g capital R square, capital G capital M by small g capital R square. So here universal gravitational constant is a constant, mass of the earth is a constant, acceleration due to gravity near the surface of the earth, that is also constant, and radius of earth is also a constant. So this whole thing, it gives us a constant. Okay, so the ratio of mi by mg, it is a constant k, or the inertial mass is directly proportional to the gravitational mass, with a constant of proportionality small k, which is equal to capital G capital M by small g capital R square. Okay, so here the main thing was that the external force acting on the inertial mass is itself gravitational force. That's why this relationship could be established, otherwise not. Okay, so for any other force other than the gravitational force, the acceleration produced is because of the inertial mass, and when gravitational force acts on the object, the acceleration, which is the acceleration due to gravity, that is the gravitational mass. Okay, that gives us the expression of gravitational mass. Okay, so now the similarities between inertial and gravitational mass are, both inertial and gravitational mass, they represent the quantity of matter in a body. They have the same units of measurement, okay, because both are in gram, kilogram, whatever you are, they have the same units. They do not depend upon the shape or state of the matter. They are not affected by the presence of other bodies. Even if other bodies are present, the gravitational mass will not be affected, the inertial mass will not be affected. And both are scalar quantities, they are not vectors. Then we have the differences between inertial and gravitational mass. So inertial mass it gives us a measure of the inertia, that is the measure of difficulty in accelerating a body, in causing motion in a body or stopping motion in a body. Gravitational mass gives us a measure of the gravitational force of attraction between the object and the earth. Inertial mass is derived from Newton's second law of motion. Gravitational mass is derived from Newton's law of gravitation, universal law of gravitation. Again, inertial mass can be measured only under dynamic conditions. That is, when an object is either at rest and some external force causes it to move and generates an acceleration A, or we have an object which is moving with a certain acceleration, it is stopped by some external force. So it has to be dynamic. Object has to be in motion, whether it is rest to motion or motion to rest, whatever it is, but motion is involved. So inertial mass can be measured under dynamic condition, but gravitational mass can be measured under static conditions. Whether two objects are at rest, they will exert gravitational force on each other. So we can measure the gravitational mass of each object with respect to Earth. Okay, so this is the concept, the basic concept of inertial and gravitational mass with their respective mathematical expressions, okay, and their definitions, then the relationship between inertial and gravitational mass, their similarities and differences. Okay, so this is the thing.